गया? ओके. Now these are the mechanical properties of nanotubes. Here we see that the tensile strength for carbon nanotube is maximum, and it is followed by silicon carbon nanotube, the hetero nanotube. From this tensile strength 10.56 GPa, it indicates that it is very large in comparison to steel. The tensile strength for steel is very less in comparison to this the strength of this carbon nanotube. So these can be a good material for anti-loading capacity, for making our spacecrafts lighter, as well as we can see the sports equipments, our badmintons and other equipments of the sports. These can be made with the help of these tubes. We had also discussed the peculiar properties of these, the electronic properties. We have discussed there that these have very good conductivity. They are good conductors also. Then, why they are good conductors? Sometimes we observe that in case of these nanostructures, if we see physics-wise, then what is happening over there? In one-dimensional materials, we have less defect. It is generally defect-free, and also there is mean free path. Mean free path is very large in case of these structures. So mean free path very large means we are having less number of collisions, so that there is not any hindrance for the flow of electrons. So these are having good conductivity also. Then these are the calculated values of effective masses of electrons as well as holes from the valence band and conduction bands. So mechanical strength, in case of mechanical strength, what we observed is CNT is having very large mechanical strength as compared to silicon germanium nanotube. Then coming to encapsulated as well as functionalized nanotubes. This is the cross-sectional view as well as the view of the wire, what is happening to the structure after optimization. These are the graphs indicating the largest or least cohesive energies. Then again, the charge density analysis for functionalized as well as encapsulated systems under our study. Then again, calculated molecular charge. These are the band structures. We are observing that the copper with silicon nanotube is having maximum number of bands crossing. Then again a comparison of the peaks, that is optical properties. Then this is the intercalation. As I had told, we also intercalated lithium, sodium as well as potassium atoms inside the pristine as well as hetero nanotubes under our studies. Again, this is charge density profile. Then these are the electronic band structures. The number of bands, the number of channels crossing with maximum or minimum. Then cohesive energies as an indication of whether the structure is stable or not. So these are the values for reflectance as well as absorptions. So this is the conclusion of the work. The dose as well as charge density profile indicates that there is net transfer of charge from silicon nanotube atoms to wire atoms. In comparison to pristine silicon nanotube, the encapsulated as well as functionalized systems in our study are found to be metallic in nature. The cohesive energy is very much for carbon nanotubes. This is the order of tensile strength. So this is all from my side. Thank you very much.